Did you know in Python you can override the standard modules that get bundled in with Python? So for example, we have a statistics module over here, and this module has things like the mode function, which you can override if you want to. So in this video, I will show you how to do this. So as you can see here, if I were to run this code, what we'll get is the mode is the most occurring number in this list. So in the square brackets, I have a list date type. These are separated by a comma. And what we're doing is the mode function can accept the list date type, and then it can work out the most occurring number. In this instance, you can see it is the number 3 that appears 3 times, while the number 2 appears only 2 times. So the output that we do get, because we do a print of this variable, which is basically the s mode function over here. So this 3 is the correct answer. And this is, remember, coming from the statistics module that comes built in Python. But let's say we want to have a module called statistics in our code that we write, and we want to basically ignore the standard module that comes with Python. So this is the basic statistics module, and we want to, for example, calculate our own. So what we can do is we can override it by just storing our code in a folder. So we're going to code our folder my code, and then in the my code folder, we would put a statistics.py file. Now you don't have to create this folder, but I've just done it to show a fuller example. So as you can see, the current statistic model over here, which is I've done a print of this S module, and you can see it comes from this location over here, which is part of the Python installation. So you can see our code lives in this my code file. And what we want to do is use this statistics file, which basically just has one function called mode, and all it returns is the value 1. So no matter what the values input are into this function, it will always return 1. So all we can do is run this code here, and what this does is it replaces at position 0 the preference and overriding the Python's default module locations. So it will give precedence to anything in position 0 when you add it to the Python path for your project. So we will do that over here, execute this, and then run our code again. And now what you can see is the output is 1 as expected, because our module is also called statistics and it is overriding the default module. And if you look at the location where it's looking at the statistics module now, it's looking in the my code folder rather than in the Python installation folder. So that's where the statistics module comes from now rather than from Python itself. So I hope you found this useful, just to know enough about this functionality within Python and how you can override the default modules in Python. Can a dog work in Python? So as you can see here, this is a dog class. And remember what we discussed about classes. Classes are DNAs. For example, if you want to breed a dog or create a dog, you need the dog's DNA, a bit like the Jurassic Park film. If you have the DNA, you are able to clone the dinosaurs. So in this instance, we have the DNA of a dog. But as you can see here, the current dog DNA doesn't do anything. We don't know what it can do. We also have a cat class here. So think of a class like a blueprint or the DNA to make real life animals out of. But what we can do is, let's say we learned something new about the dog. So what can a dog do? Well, a dog can speak. So it can say hello. So if we wanted the dog to say hello, then what we can do is we can write a function. So I will take out the word pass. Pass was added in as a placeholder until we add real code. So I'm going to use the keyword def in here, and then I'm going to call this function speak. And this function needs to take in one parameter called self. This self parameter is very important because when we create a clone of this dog, this speak function will execute on that specific clone that we are creating, because each dog may sound differently. So in this instance, if you give a dog a name, it might speak its own name rather than just any random name. Then we're just going to write 2 colons. And for now, for simplicity, we will just write print function that says hello, and this hello will get printed out when you create a clone. So let's create a clone. So we're just going to add another code line here, and we're going to say d is equal to dog, and then we're going to call the speak function by calling d.speak, open parentheses, close parentheses, and we are now going to run both our cells. So click here to run this cell, and then we're going to run this cell. And you can see here that a dog has spoken and it said hello. So this is how you write a function in a class in Python and essentially get your dog to do something rather than nothing. And as you can see, our cat class at the minute does nothing. So dog has the ability to speak while the cat doesn't do anything. So our dog can finally say hello. So here you can see we have a speak function for the dog, and the dog can say hello to us. But what we really want is we want the dog to say its name. So we need another function for this. So let's create a function for the dog so it can say its name in Python. So we will add another def. Def is the keyword you use to define a function. And then we're going to call it say name, and we're going to do open and close parentheses. Now, as we said before, we can put 2 colons here, but we forgot something very important in the parentheses. We need to add the keyword self, because every time we call this function, remember, we will have cloned the dog here. So this is the DNA, the class in effect over here. This all is the DNA of the dog. And when we create a clone of it, we just want to refer to that specific clone of the dog rather than any random dog. So we want that specific dog that we have just created here in this variable called D. So you always add the word self, and that is called an instance variable. So you might say it's a variable that belongs to the clone and only that specific clone which is in this variable. So we will then get the dog to say its name. So we will use the print function. And we will get it to say my name is, and here we are going to add a comma and then self. Now remember, self is that particular instance, and then we're going to say name. This is going to create a variable name, and this name variable can then be used to give the dog a name. So here, when we create a dog for the very first time, we will add another line here, and we will say dog's name is equal to Rex. So we have given our dog a name of Rex. So at the minute the dog will speak, say hello, and then also we want the dog to say its name. So again, open and close parentheses whenever we call a function in Python. So now when I run this, so if I run this one first to make sure we have this function available, and then click on here. And when you run this, you can see the dog says hello and then says my name is Rex. This is because we have given that particular clone the name of Rex and using self.name, self to refer to that clone, that specific clone of a dog. And that will have a name here given by the owner. So the owner has created the dog and given the dog a name. And then we just say to the dog, now you know your name, so can you please say it? And this is how you use instance variables in Python. And to be more specific, class instance variable. Hello, everyone. So today we're looking at this capitalization method in Python. So here you can see that I have a property called name for this dog. So I have a class here, and this class allows the dog to say hello, but also the dog can say its name. And the name here you can see is taken from the class instance. So the self keyword points to the instance of that particular dog. So here, when we create a new dog, we give it a name of Rex. But what I want you to notice is the name here is lowercase and the name here is capital letters. So when you do this, what do you think will happen? So if I were to run this code, you can see that it prints the name Rex rather than Brand. So what's happening is the variable here name is different to the variable name over here. So these are classified as 2 different variables. And again, such as d.name in all upper letters, that would be again a different variable. And same with any other combination that you get, for example, N, A, and then M, and then lowercase e, that again would be treated as another variable. So what you need to do is always ensure that you use the correct casing for your variables, otherwise your code won't work. So for example, if I change the variable here to name and then do a capital E at the end and run this code, you will see that the code will not work because it says it cannot find the attribute name, which is used in the class over here. So the name can't be found because we have changed it to capital N, A, M, and then capital E, which is different to the one over here. So always ensure that you use the correct casing in Python, especially when you're declaring and using attributes, as you may accidentally use different casing for your variable names, which could cause problems. Hey everyone, today we'll just look at dynamic objects in Python. So here you can see that I have a dog object. This dog object can speak and basically say hello, so it can print a hello message. And the next thing it can do is also say its name. So here, down here, we can see that we are creating a dog object out of this class, and we are giving it a name of Rex. And then we say, can you speak? And then we say, can you say your name? Now, one thing I want you to notice, which is very important, is here, when we say print your name, you can see that nowhere in the class I am declaring a variable that is basically named. So what's happening is Python is dynamically creating the name variable in the background. And I can prove that because what you can do is you can change this and add new properties such as age equals 2. So here, Rex is now 2 years old. And what we want to do is we want to see if that age property is mentioned anywhere in the class. So you can see down here, there is no mention at all of something called an age. But yet, when we create the object in this variable D, we are able to give it age of 2. So if I were to print that out, so that's to prove that it does exist. So what we're going to do is we're going to print d.age. If I were to run this, you can see that the dog says hello and also says my name is Rex, but also we have the age of the dog. So the important part is you can continue to add more properties to your object here. So here you can say, for example, the dog has a favorite food. And in this example, let's just say it's a cake. So you can see here that the favorite food property again doesn't exist. And in this fashion, you can continue to add more and more things. So here you can add favorite sports, for example, and you can then say it's actually running. So here, these properties or attributes are being added on every time to the class, although they are not in the class blueprint over here. So you can just add these. So this is a slightly different behavior to some of the other programming languages. And that's why Python is really popular, because it lets you do things like this, which other programming languages either frown upon or make it hard to do. Hello, everyone. Oh yeah. So this one is an interesting one. So do you know what this code is doing? If you don't, then watch this video and I can explain what this D__dict__is doing. It's very important that you understand this. So as you can see here, we dynamically added in properties to our class. So here we have a simple dog class, and you can see the dog can say hello and the dog can say its name, and it's using the name variable here or the attribute which we defined here. But what you notice is we also defined these other properties: age, favorite food, favorite sport. But where are they in the class? Can you see them anywhere? Can you see them anywhere at all where I've declared them? So this is one of the strange and funny behavior with Python, but also the most lovable behavior is its dynamic objects. So dynamic objects are very important to understand. So what's happening is every time you add a new property, even though the class blueprint doesn't have anything in it, you can just continue to add new properties. So favorite food, favorite sports, and for example, I could add in another one called favorite person. So that could be, for example, John. So here, the favorite person is John, and you can see the favorite person doesn't exist anywhere. So if you were to run this code here and you were to print this, what you will see is Python, all these attributes that you have here are being stored in a dictionary. So when you print that, you can see here, name is stored here. So key value pairs, that's what a dictionary is. It's a key and then a value, a key and then a value, a key and a value, a key and a value. And that's how it continues. So you can see all the properties, including the favorite person we've added in, and the favorite person is John in this instance, is actually being stored into this dictionary, which is this hidden object that you cannot see, but you can of course access. So it's __ dictionary. So this comes as a standard. We haven't declared it in our class over here. It's just part of Python features that you get this with its objects. So here, when you print that, that's where all your dynamic properties are being stored in a dictionary. Hence, when you access self.name, it's able to go to that dictionary and extract the name part, and then it prints out my name is Rex. And same here with the age. When we print the age, you can see it just prints out the age. And if we wanted to print another one, so the favorite person, we can just do print and we can do d dot favorite person. And if I were to run this, you can see the favorite person is printed here, John, which it just retrieves from the dictionary over here. This is the key and this is the value. So yeah, just remember this underscore dictionary is being used by Python to store your object properties or attributes. And this is a bit different to other programming languages which do not let you add in dynamic properties like this. This, what you might say, is a strength and a weakness of the Python language. Hello everyone. Can Python have more complex attributes or properties for your class objects that you use dynamically? So you can see here in our class, we have a class called dog and it's able to speak. So it has a method called speak or a function called speak, and it can also say its name. Now, one thing that you realize is Python is very dynamic. So it lets you add in new properties to your class without actually declaring them anywhere within your code over here. So, but can it have any more complex properties than simply numbers and strings or numbers and letters? Can it have anything more complex? Yes, it can. That's the answer. So here, for example, you can add in favorite colors. So by adding favorite colors, and I'm going with the classic red, green, blue, and here this is a list data type. The reason it's a list is because of these square brackets and commas separating the list of items, just like a shopping list is. And here you can see, you can also add, for example, a dictionary data type. So what is the dictionary data type? Well, what it is you recognize it by these braces over here, and then you have a key and a value, So here, for example, Rex's father, his name is Mex, and Mex lives in a location called the city. So you can have complex objects like this. So if I were to print this over here, and you can see here that we've got the following output. So we've got the simple properties. Remember, all the properties attributes are stored in this special variable behind the scene that Python uses. So that's why it's able to dynamically add in these properties without declaring them in a class. So it uses a dictionary. You can recognize it's a dictionary because of the curly braces here or curly brackets. So you can see here, for example, Rex's name is stored here. Age is stored. Favorite food is cake. Favorite sport. But as you go along, you can see we added the complex list. So that's his favorite colors. And you can see the list indication here by the square brackets. And then you can also see that although the dictionary here, all this is stored in a dictionary, but we can have a dictionary in a dictionary. So here for father, which we said here. So you can see father is here, and we said father can actually have properties of its own. So father has a name and a location. So name as Bex and location as city. You can store very complex data types as properties of objects that you create dynamically in Python without first declaring them. Hey everyone, so rather than declaring properties in Python like this dynamically, where you can just go crazy and keep on adding properties and so on, there's a more professional way of doing these kind of things, but actually less error-prone way of doing things. So here we can see we have a dog class that we declared above, and we are then going to give the dog a name, an age, favorite food, and so on. But rather than keep on adding these properties dynamically because they are nowhere mentioned in our class, what we should do is we should use this initialize method. So this initialize method or function ensures that your properties are declared when you create the object. So here you can see we created the dog object, but we didn't really pass it anything. We created everything dynamically over here. So what we can do is we can actually now use the def keyword. So remember, this is just like any other function. So you use the def keyword and just use this underscore here. So these are two underscores for your information. So you just do underscore, and then this cell, of course, is just referring to that particular instance. So you always use that if you want to work on any variable or access any variables within your code that belong to that particular instance. So here, what we're going to do is when we say dog, we're going to give it a name. So in this instance, we're going to pass the name in this fashion. So we will give Rex, and we're going to give age of 2. So then what we can do is we can take out this bit. So we don't need these two lines, and I will leave the other dynamic properties just to show you that you can continue to do that. So mix the initialization properties as well as dynamic properties mentioned here. So you can do both. So what we'll do is we will run this code over here, and then when we run this code over here, you can see that we still get a hello from the dog and we still get the name Rex. This is because when we call the say name function, it prints self.name, which you can see is being assigned here in the initialization method. So the name and the age get transferred here and get transferred into self.name and self.age. So then you don't have to dynamically declare them, but you can dynamically declare them here. And you can see it does have the same effect as before. So name is stored here as Rex, age of 2. So all this is still stored in this dictionary variable here. So that's just something built into Python. And you can see here we call the same name method over here, which basically prints the name of the dog. So rather than dynamically create them, we created them when we created the instance or initialized the object of a dog into this variable. So this is a better way of working with properties rather than dynamically creating them like this on the fly. Hey peeps, welcome back. And you might be wondering, what's the benefit of doing this? What's the benefit of this method over here? Why would I even use it? If I don't have to, why do I bother? I can just create properties in Python, class objects dynamically. So, I can give the dog its favorite food, favorite sport, favorite person, favorite color, father. I can do whatever I want dynamically. So why would I want to create, use this initialization method over here to declare the properties like this, assign them like this? Why would I do all this work for, no benefit? Well, I think you need to understand the benefits of doing this, because what happens is when you declare properties like this, which is you are asking the person who will use this class. So here, this, for example, somebody who's using the class, in this instance, it's just myself who has written this code. I am saying you have to supply the dog's name and the age. So these two variables are there. So when you hover over the class, you can see it's documented. It needs a name in the string format and age in the int format there. Now, this string and int are actually being built in here because you can easily change this into something else. So for example, you can change this to a string. And now if you look at it, it will still accept a string because Python is not very strictly type language. So you can change the type dynamically whenever you want. So, but the benefit here is you get the documentation here. So, the dog class has a property called name and age that you have to assign. So what we can do is you also get options like this. So when you type D and you type name, you can see that the name property appears there. So that's the attribute that we created. Whereas if you didn't use that, so for example, if you didn't use that, and for example, the say name is self.name, you could easily make a mistake, because if I take that out, so let's just take that out. And if we just take that bit out, and what we're going to do is we will say d.name is equal to Rex. What happened now is you have called this lowercase name, while here this is an uppercase name. So this is going to cause problems, or you may actually end up doing plural. So even though you have name, or you make a typo like names rather than name, then of course your code is not going to work. So if I run this here and then run this, you can see that we get an attribute error here that basically says it cannot find name. So if I go back in here, if you had to use this, then you know that you will have a property called name and it will be assigned when the object is created. So it makes everything a lot easier. So this is one of the main benefits, is documentation. And actually you cannot make mistakes in the naming of the properties if you created them dynamically. So if you create them dynamically, you will make a mistake. But if you use this initialization method, you are less likely to make a mistake. So I hope this makes sense. So I would encourage you to use initialize method to create attributes and properties. But of course, the flexibility of dynamic properties and attributes is perfectly fine too. But anything you can create within the initialization is much better.